Has anybody heard of these things besides you? Have you?
Closure.
Oh, I've told you about them. Yeah. Anybody else?
I've heard that from him.
Yeah? Anybody that doesn't know anything about Clojure heard about these things?
I told everybody.
Kind of.
Okay. So, what are these things? I mean, so actually I'm glad JP showed up because I was sitting at lunch having some fun with him, and he asked me what I was working on, and I told him, well, I'm really interested in these transducers things. And about 20 minutes later, his eyes were glazing over and he was drooling a little bit. He stops and he's like, why? I mean, why are we using these things? What's the point? So I don't know if I can answer that, but I'll start with a demo. This is one of the libraries I'm playing with. It's called _transducer. I'm using, actually, so everybody knows, I'm assuming everybody knows underscore, or most people, everybody's heard of it. So this is taking the underscore API and actually creating transducers, or using transducers in that kind of context in that API. But what really got me interested in this thing is actually not really, most introductions actually introduce these things as kind of a lazy way to process a list, to actually go through each item at a time and filter and have and that sort of thing. But you can actually use these in different contexts. And one of these ways of, has anybody heard of reactive programming, reactive Cocoa, reactive extensions, there's a bunch of other NebraskaJS. It's actually a way to actually define the operations on strings of data. So here you actually have an event listener. It's just jQuery. You add an event listener to mouse move, and then you call this. I have this as callback function. So it creates a function and it runs it through this transducer right here. Actually, each is a transducer. So it calls on every mouse move. It actually calls this function. You get these live outputs in here. You can do anything else. You can map over. So this is your mouse event. So you can get your client X, your client Y, map over that, and then the ref them in parens if you want, and then call this update text method or function. Same thing. And here I'm actually adding a listener mouse move and click, adding it to this events handler. It's a function again, and then you can do this. So you can click on it, you can move it around. Another way, I mean, this is using filter and take. So this is actually creating it's like an infinite iterator where it actually, is this what it is? Numbers. So I'm taking the first 10 odd numbers out of this this random generator. So it's just generating random numbers, and that takes the first 10 odd, or divisible by 3 actually, numbers, and then every time it does that, it takes the first 10 random numbers that are divisible by 3. So there's a bunch of examples like this that I'll go through. There's another one called underarm that actually, it's like underscore transducer, but it's adding the ability to do this asynchronously. So you can actually do this with promises within your, so you can actually query like a AJAX callback here. I'll go down the bottom. This is just it loads this CSV file with AJAX. It runs it through this async, grabs the first item, and then maps it over load athletes, which is another function, and display athletes. So you can just grab it and run it through this function and display it. And here's using the same thing, mapping it from this row to TDs, so you actually create a table. So I mean, that's my demo. Any questions on this? I'm going to explain them later, but hopefully I'm kind of give you an idea of what you can do with these kind of things. This is just a few examples. Just any questions so far? No? Okay. All right, so that is why. So what are these things? So these actually come from Clojure, the name anyway, and the idea. And if you go to the Clojure website, you'll actually get this explanation. There are composable algorithmic transformations. We'll talk about all of this actually. Some of the key points in here, though, I'm not going to read it all to you. The independent context of the input and output sources. What that means is you can use these with a lot of different things. You can use them with arrays. You can use them with promises. You can use them with event streams, anything like that. That would be your input source. The output source, you actually can send them anywhere, basically. You can transform an array to an array. You can do a event source to an array. You can take an ES6 iterator and then make an array. You can do it over objects. You can do it over lists. You can do it over immutable list. If anybody knows immutable JS from Facebook, you can use these with that kind of thing too. And we'll talk about how that actually works as we go. So you can use them in many different processes: collections, strings, channels, observables. So observables would be things like, well, event listeners, I guess would be an observable. Other things would be for like reactive extensions. They actually define their API based on an observable, which is a callback. Every time you get an event, you actually push data through this chain, and then you can do operations like you would see an underscore, like filter and map and take and anything like that. Channels, actually, that's if you've heard of CSV, core async, that would be the channels. Strings would, I don't know if it's in context of closure, but you could use these things with Node.js strings. You can take you can actually process a Node.js string lazily. I mean, you can actually use transducers to split over the string as you're pushing the data through it, and lazily like parse a CSV file as you get a data, like live streaming of this data and parsing the CSV file using these things. So the compose directly, we'll talk about that a little bit later. Without awareness of input or creation of intermediate aggregates. So what the intermediate aggregates means. So if you're using an underscore, for example, and if you're using the chain API and underscore, and you say, well, I have this, and we'll talk about what all these mean. I'm not sure, but like we have this, we're going to map it to uppercase, and then we're going to filter everything that starts with A, and then we're going to take the first 10 items. Actually, so if you're actually running this through an underscore, every time you do any of these operations, you're going to create an intermediate array. So every time you map, you're going to actually create an array at every step. So the intermediate aggregates actually refers to that. These would be the arrays at every step. We'll talk about this later. But you can actually process this at a step at a time. And if you look into this, actually one of the main benefits, actually, if you have maybe heard of like Highline.js or Lazy.js or anything like that? No, it's the same idea, that you can process items one at a time, and you push it all the way through the chain instead of creating arrays at each step. Does that kind of make sense? We'll talk about it more a bit. So that's what transducers are. This is, if you go to the closure.org transducers URL, you actually get this as an explanation. So we're going to take this as an explanation, actually break it down, and we're going to walk through a bunch of JavaScript. This is going to build on top of each other, so at any point if you have a question, just stop me, because the further I go, the deeper we're going to get. So if anything doesn't make sense, stop me and we'll talk about it as we go. So, any questions so far? I forgot I have a slide in there. So these things do come from Clojure community, but there are things like this out there. One of these, is anybody a Haskell programmer? Maybe not. There's actually a library in Haskell called Lens. It's pretty mind-blowing, actually. I'm not quite sure if I understand this library yet, like most things in Haskell. But this is actually just a package within this library called lenses. And the way these things are defined are very close to how transducers are defined. So this idea is kind of in the Haskell community as well. I just thought I'd point that out because these ideas are out there. I don't know if it quite gets there, but it's a similar concept. Okay, so how are these things implemented? That's what this talk is really about. So what I'm going to do, I'm going to actually run through a bunch of JavaScript, and everything from here out on is just going to be JavaScript code. So let's cut it off a little bit. Is that all right? Or should I reduce it, the screen size? Can we read this here?
Is it possible to turn down the lights?
Maybe.
My main guy isn't here. What have you done?
There you go. Is that better?
Well, but now there's light on the screen.
Just work. Can everybody see this? Fine. It'll actually get bigger. This is probably the most dense slide I have, actually, but it's really just So does everybody know what reduce does? Does anybody know what reduce does? Fold left, it's also called. It's a method, or it's a method on a JavaScript array that you can call. And it basically takes, all the traditional use is actually taking this list or this array and reducing it using some operation, some binary operator to another value. So here we're actually defining it twice. So that first output there, that where you do 2, 3, 4 down, reduce sum 1. That's just calling reduce an array. It's available since ES5, I think. And it's passing in what Clojure actually refers to as the reducing function. In this case, it's sum, and it gives an initial value. So what's happening there, you can think of reduce as just a loop, really. I mean, this array reduce is doing the exact same thing, just reorders the R's a little bit, and takes a step function, which was the reducing function, initial value, init, and then the array to reduce. So all you really do is you start with initial value, you loop over the entire array, you call this step function for every value, and then you return your result. That's all reduce is. So here in the case of sum is just result plus item, so it's taking two values. So the first value, first time you run through it, you start with init, which in this case is 1, right? So you start with 1, you iterate your full array, so you have 1 plus 2, and you actually get 3, and then you get 3 plus 1, and then 4 plus 1, right? So you take this list of 1, 2, you take this list, or this array of 2, 3, and 4, you start with a value of 1, and you get a sum of 1, 2, 3, and 4, right? Does that make sense to everybody? Any questions? Okay. So here's the same thing with multiply. The only difference here, if you look, is we're passing in multiply instead of sum. And it works the same way, except for the operator in between, the function that you're calling in between is multiply instead of sum. Okay? So when we're talking reduce, that's all we're talking about. And then when we're talking about reducing functions, all we're talking about is a two-word function that takes they call it an accumulator usually, an accumulator and an item from your iteration, and somehow you combine those two things. Okay, so here we're combining it with multiply. In the sum case, you combine it with plus. Does that make sense? Okay. So yeah, so sort of terminology, reduce, the reducing function is the function you pass to reduce, and the initial value is the second argument to reduce. So really we're going to take this reducing function and actually break those steps apart. You actually, and we're going to call it a transformer here. And really this is just an object. It has 3 functions. It takes your reducing function, calls it step. So before this would be sum and multiply if you're using what we saw before. We have an initial value. Here we're just going to return 1. And then the result is something that we'll see later, but right now you can think of result as just going to return the result. So if you go back and look at reduce, the init would come here. It would be your initial value. Your step is what you do on for every item in your array or your collection. And then at the end here, you can actually do something before you return the result. And that's what result is for. And we'll see that later. But the most important thing in here probably is the step function, the reducing function. And that's the step, because that's what you take with every value of your array running through that function. You okay so far? Okay. So what can you do with this? It's the same thing. I mean, so we're actually taking the input source, that's just the array that we saw before, 2, 3, and 4. We create a transformer actually and pass in our sum function. So that's just creating this object here that plugs that sum into the reducing function. So right now, if you see here, this xf equals transformer sum, you're creating one of these objects that has an init, a step, and a result. And if you call step, you're actually calling sum. Okay? So we start with the initial value, we just call it xf.init. And then we use just that array reduce, the same method on an array, JavaScript array, to use the xf.step, which in our case is sum, and pass on that initial value. And this value, and then the final thing we do is we take that result and we pass it to result. And you'll see why we're doing this in a minute, but do you follow this slide so far, what this is actually doing? It's the same thing we did before, like giving different names to the steps. Same thing with multiply. The only thing that changes is the function, just like we saw before. That's just going to change your output because you're using multiply instead of sum. Okay. All right. So we're going to define a function called reduce that just does what we just saw on the previous slide. All it does is takes xf, which is our transformer that has a step function and a init function and a result function. We're actually going to pass a init in just to match the API of the method, the reduce method, and then use the xf.step for reduce. That's the function we pass to reduce. Remember, that's sum or multiply. And then before we return that result, we'll just call this result function. So that's reduce. It's the same thing as an array reduce, except for we're working with things called transformers that have an is, step, and result. Okay. Yeah, let's do it. All right. So reduce. Again, and we're just redefining reduce from the arrays. We're actually reusing the reduce right now from arrays. That's what input is right now. Input is an array. Our reduce with a step function from our transformer, pass an initial value, and I call result before we return it. So that's all reduce is. So any questions before I move on? Okay. So it's just walking through it again. We're using actually reduce, the function that we just created with transformers. If you remember our init, we're just returning one somewhere. So init is one. We're passing in sum to this transformer method, which is just creating this transformer. So step is our transformer, but since our reduce actually accepts transformers, now we just pass it in. I mean, it'll work with this transformer. So this transformer function actually wraps a reducing function, which is what we just saw before, sum or multiply, and then we can use reduce with it. Same thing with multiply, same thing before. We're using multiply instead of sum. So this is just indicating most of the time you're actually passing in a different initial value. You're not calling this xf.init. In fact, you'll probably actually, the implementation within Clojure, as far as I'm aware, doesn't actually call it an init right now for either any of these methods that we're going to look at today. You pass that into the function. So here we're just changing it to 2. The only thing it's going to change is that that initial value here, that first number here is going to change from 1 to 2, which is just going to change our result. It's going to multiply it by 2 instead of 1. So it goes from 24 to 48, just by changing that initial value. Here we just change the initial value for sum to 2, so we get 11 instead of 10. Okay, so we had the ability before to actually use a pass a function to reduce. So we're just going to modify our reduce to allow a function again. And that way we can just pass sum in again directly instead of calling transform on it. So this is the exact same thing we saw before. We're just calling reduce and passing it to result. But before we do that, if just what we pass is the first value, which could be either a transformer with step and init result, or it can be a function. If it's a function, it calls this wrap method, which is just what we saw before. We don't need the initial value, so we pass it in. The step function or the reducing function is called step, and the result is just going to return you back to result for now. It's just an identity function. So we just added the ability again to pass in functions for reduce function instead of transformers, or in addition to transformers. Okay, so this is just showing you can do it. We're passing in sum, which is a function, calling reduce on it. Calling multiply, passing in multiply a function, calling reduce on it. You can call this wrap method externally, which will create that transformer and use the same function. So you can either pass in a function or you can pass in a transformer. That's all we're doing here. Same thing with multiply. Okay, so are you okay so far? Yeah. Everybody following? All right. So so far we've just seen sum and multiply. You can also do this with arrays, actually, with the concat method. So what concat does, I mean, if you're not familiar with that, that's just going to take the item and just append it to the array. So you can think of this as just pushing a value onto an array. You take an item, the result in this case will be passing in an array, so the result will always be an array. And you call it concat with an item. So all we're doing is we're going through every item at a time and adding a value one at a time onto the array. So we're pushing items onto the array. Does that make sense? When you do it just with reduce, I mean, it's not very interesting, actually. All you're really doing is copying an array, because you're taking this append function, running 2 through this function, which is just going to get you 2, and you run 3 through it, which is going to get you 2 and 3, and then you run 4 through it, and you get 2, 3, and 4. So all you get is a copy, which isn't very interesting. But it gives us some. We'll see how we can actually use this later, where we can actually make a transformation on that array before you get that result back. So that's append. Append just concats an item to the array. You can do one at a time. So it's a reducing function that you can pass to reduce. Your initial value is going to be into your array, and your input's going to be the array that you're reducing over, just like we saw before. Okay? All right, so +1 is just going to take item and increment it. We're going to create a transformer out of that. So just like we saw before, the nit is going to throw an error because we're not using it. Results just an identity because we don't need to do anything on result. But our step function, in addition to appending, like we saw before we do that, we're going to call +1 on it. So we're going to take that item, increment it, and then append it to the result. We can use this transformer with what we saw before, but we're going to do it actually manually. So we create this +1 transformer, start with an empty array, and every item we have, 2, 3, and 4, we're going to call step on it, which is actually concat. Well, it's concat and +1 right here. This is our step function. You add 1 to it, and then you call append, which is a concat function. So if the first time you step through it, you start with an empty array. That's going to be your result or your accumulator, and then you're going to get your item +1. So then you're going to get 3. You call it again. You have 3 because of this result, and then you're going to take this 3 +1. Right. So then you have 3 and 4, 4 +1. So then you end up with 3, 4, and 5. The result just returns whatever you pass it in the space. So we're just going to get that right back. Okay. All right, so what if we want to actually sum this result? I mean, we could just use reduce here, pass in this output, which is 3, 4, and 5, and then pass in 0 for our initial value, get a sum of 12. But what we actually need this intermediate array, this aggregate. So we had to create this array here, and then we actually essentially called reduce over twice. We did it manually once, and then we had an array, and then we're going to actually reduce over that with sum and get this 12. We can do better than this, actually. So if we define so instead of so we create another +1. So this is the +1 transformer, and instead of appending here, we're actually going to call sum. So if you remember before, I think that's my next slide. We're calling. Oops, sorry. Okay, so before we called append here, but we're going to change that to sum. And this way, when we run it through this transformer through the step function, instead of creating an array first, we're going to be calling sum instead of append. And then we can just get it in one pass, instead of creating this array and then calling reduce on array to get the sum. So the only thing that changed between these two transformers is that function, the reducing function, sum and append. So since that's the only thing that changed, we can actually pull that function out and actually wrap it in the transformer. And if you remember, you can create a transformer with both the appending and the sum. and you can pull that operation outside of this transformer and pass it in. So instead of sum and append, you can pass that operation in externally from this transformer. So here at this step function, you can imagine you can either pass in something that has append, or you can pass in something that has sum. But you're passing it in at an upper level. You can see there's actually a nested function there. This is a function that accepts another transformer. That can be sum or append, and then you're calling step on that for every item you get through. Does that make sense? So how would you use this? And so this is actually a transducer. This is the first time I would see. It's basically a function that accepts something, a transformer that has an init resultant step in JavaScript, and can actually do something with every item, but then forward it on to the next transformer. And the next transformer is the one that you pass in. So that XF that you pass in, we're going to take every item, we're going to add one to it here, then we're just going to pass it on to the next one. And the next one, in this case, as we'll see, would be sum or append. So here's using this function. You wrap append to create a transformer. Again, all that's doing is taking this append reducing function, calling it step, giving it your init and result. We're using this transducer plus one, which is what we just saw on this previous page. And then we're passing the stepper, which in this case is append, to that transducer. So what that's going to do is pass it through, and it's going to return this object, this transformer object that has a step function. But what you pass in is actually what you want to do with it after you're done with plus one. Okay? So after you have this transducer created, you can manually step through it. Again, we're just passing init. So init 2. So what that's going to do, first it's going to do the plus one, because that's what we're doing here. We're doing plus one item. And then you say xf.step, which is our transformer, the result, and that item that we just incremented. So it's going to pass 3 to append, which is going to just append 3 onto your empty array. Are you following? The next step, you have your 3 in your array. So you have an array with one item in it, which is what you had in your previous result. You take your 3, you add 1, because that's what the plus 1 does, and then you append it, because that's what the stepper is. And then you go on and on. So you end up with 3, 4, and 5. Result just returns back the result. Okay? So it's the same thing. The only thing that we're changing here is the append, which is our reducing function, and the initial value. So we're changing the reducing function from append, which works with arrays, just adds items to an array, and we're changing our initial value from an empty array to 0. And everything else is the same. We're using the same transducer. We're initializing the transducer with this wrap transformer. But in this case, instead of wrapping append, we're wrapping a sum. And then when we start with our initial value, instead of working with arrays, we're working with numbers now. But it's the same structure, we're just doing it in one pass. So yeah, the functions change, the results change, just by changing that stepper function, that reducing function, and the initial value. Okay? All right, so what if you wanted to create the same thing with plus 2? I mean, you want to add 2 to everything instead of 1 to everything. What would you do? Well, you could do what we just did before. This is what we did before. We had a transducer plus 1. The only thing that would have to change there is the call to. Instead of plus 1, we actually have to call plus 2. And it's pretty simple. Same thing. We just create this thing. We create a wrapper over that function, and then we pass it to the next result. Okay? But, I mean, so since that's the only change, you can actually pull that function out, just like we did for the transformer, and pass it in. So that's what this is doing. everything was the same before, except for now you have another function that accepts f, which is a function, and then it returns a transducer. Well, is this a transducer? Yes. So it returns that what we had before. So you're passing in the function that you want to call on every item, and then you get a function back to pass in the transformer that you want to do with the next item. So you have a function that's returning another function that accepts the transformer. So the transformer is actually for the next item. The f, the function that you're calling, is what you're doing on every item. So it's just like what we were doing here, except for we pulled +1 and +2 out, and we're going to pass it in and call it f. Okay? Any questions? Okay, so this is actually the mapping transducer. Map, I mean, if you've seen it before, if you use an array.map or _map or anything, it just takes every item in an array or a collection. It calls a function on that collection, and then you get the same collection back as a result after calling that function for every item. It's the same thing, only in transducer form. Okay? So here we can do the +2 transducer using map. And all you got to do, if you remember before, we had the transducer +2 that we defined manually, but since we have this map thing right now, we can use that, pass in +2, because that's what we want to do with every item. And then everything else is actually the same. We're wrapping a pen. That's what we're going to do with our data structure that we're starting with. The initial value, we're starting with an array, and with every item we want to append onto that array. So that's what the stepper, the wrap append, and the initial value do. The transistor is initialized with that stepper, but then the transducer is created by using map, passing in +2. Everything else is the same. It works exactly the same way as what we saw before. The only thing that we changed is this right here. Instead of having to create this thing manually, we can actually use this mapping transducer to create our +2 transducer. Okay? And the same thing, so now we can use this for +1 as well. Use the same function for either or. You can have +2 or you can have +1, and everything else is the same. Okay, so what are we doing? So we first create a transducer. Right now, the only thing we have is the map. We create a +1 transducer using the map just by passing a function to it. We're creating a transformer that the transducer can use using a wrap. All it's going to do is append to the array, and then we need an initial value. And then for every input, we're just going to call step on every input. That's all we do. We just call step, 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 step. We pass in the result of every intermediate value. Start with initial value. And then finally, we just call result on it. Okay? So, I mean, does this remind you of anything? I mean, all this is actually, if you look at this stepping, you start with an initial value, you just call step for every item in your iteration, and then you call result. Well, that's actually what we defined before. That's just reduce. That's all it's doing. You can actually do the exact same thing by passing in this transformer created from the transducer as XF. Remember, this accepts anything that has a init, step, and result, an initial value, and your input array. So instead of just instead of pushing 2, 3, 4 manually through it, you can just pass it through it or reduce. You get an array that does the same thing. Okay? So this is just cleaning up a little bit. I'm removing comments. Just calling reduce on it. The stepper, we're calling wrap right now just because we need a transformer. We can do just what we did before by, hey, if it's a function, why don't we just wrap that as a transformer? So that's all this is doing. Same as what we were doing before, except for we're checking to see that stepper is a function. If it is, then we're going to make a transformer out of it. And this is the same thing. We create the transformer using that transformer, and then I'll reduce on it. Okay? Any questions? So this right here, block of code, is actually what's called transduce. So this is exactly what we saw in the previous slide, or just calling it, we're wrapping it in a function, passing those 4 top items in, and it's called transduce. So you accept a transducer, a stepper, initial value in your input array. Well, in this case, it's an array. If it's a function, you wrap it into a transformer. You initialize your transformer with the transducer, if that makes any sense. And then you call reduce on it. Okay? That's transduce. That's all transduce does. All right, so now that we have transduce, our previous slides become much shorter. I mean, we're just saying we're creating, and these are all utilities that are actually provided for us. The only thing we're providing, the only thing that we need to provide is a function to do what we want to do. In this case, it's appending items to an array. You got to pass in an initial value, and you got to pass it in something that you want to transform. So the transducer here is using our mapping transducer function that we created, passing in +1. That's just a function that adds 1. Remember, this is just our array concat that just takes the array as the first item, the item for the second item, and just calls concat. Initial value is an empty array, the inputs the 2, 3, and 4. If you call transduce on it, for every item it's going to reduce, it's going to say 2 + 1 append, 3 + 1 append, 4 + 1 append. So you get 3, 4, and 5. Okay. Same thing, just changing +2. Everything else is the same. You just get +2 on every item. So here's actually the same thing, except for we're changing our stepper, our reducing function, and the initial value. So we're summing over items instead of appending over items. And everything else is the same. You use the same transducer, you use the same function, you use the same transduce function, but instead of appending, so instead of getting the 3, 4, 5 array, you're getting the sum of it because you're passing it sum and 0 for your initial value. Same thing with +2. So you're adding 2 to every item, calling sum over it.
Quick question.
Yep.
So I imagine you can wrap another transduce function and pass this output as an input to another transduce function.
Right.
Okay.
Right. And we'll get to that actually.
Okay.
Yep. But yeah, that's actually kind of the point.
Oh, God.
Okay. Any other questions? Do we understand what's going on here? Okay. Same thing with multiply, +2, just a bunch of different examples. So +3, I mean, what if we want to add 3 to every item? So, well, yeah, we could use the same function. That's pretty boring. I mean, we already have +1, +2. Can we make use of that? And it turns out we can in several different ways. So we have +1 and +2. We can actually define +3 in terms of +1 and 2, +2. It just looks like something like this. I mean, you pass in your item, you call +1, or you call +2 on it, get a result, and then you call +1 on it, get a result, and then you return a result. So actually, does anybody know what this is? This is actually, well, there's a hint right there. This is function composition. So you can do the same thing, only you can pull these 2 functions out, the +1 and +2. You can pull that out and pass them in. So this is actually functional composition, but in this case, it's just 2 arguments. You've probably seen this before. It's just a way, you've seen it in math, I'm sure, where you do f of g equals f of g of x. All you are doing is you're passing in 2 functions, and you get back a function ready to accept whatever you want to do on it. And you run those functions right to left. So the first thing you call function 2 on it, you get a result, and then you call function 1 on it, get a result, and return it. But you're actually returning this function. So you actually have a function that's ready to accept your item to do these two operations on it. Does everybody understand that? Okay, so if you have this compose to function, you can actually create +3 in terms of +1 and +2, right? You say, well, I want to add +2 to it. I want to take an item, add 2, and then I'm going to take that result and add 1, so that you get 2 + 1 is 3. This is just showing you the output. We're just calling +3 on it, 3 different items. So 2 + 3 is 5, and you can create an array out of this compose function. Okay? So does this make sense to everybody? All right. All right, so yeah, you can create your transducer +3 using what we did before, since you can create a function called +3 that just returns item +3. And just go through it. It's going to do exactly what you expect. It's going to add 3 to every item. But since we have compose, and we have +1 and +2, you don't actually have to create your +3. You can define that in terms of +1 and +2 using compose. Right, and then call map on that function and get the same result. It turns out, just because if you remember, actually the transducer accepts a transformer and returns a transformer. So it accepts an item that has 3 functions and has step and result, and returns the same type of object that has an if step and result. So you can compose, instead of composing the functions and then passing it to map, you can actually compose 2 different transducers, and it'll just work because of the way it's set up. So it's map +1 minus +2, you're getting those 2 transducers that we saw before. The first one adds 1 to every item, the second one adds 2 to every item. If you want to, since you have those functions and you can create transducers out of them, you can actually compose those 2 transducers and everything else will work. And that actually is kind of what you do. Okay. And this actually boils all the way down. You can use compose 2 as much as you want. So here, what am I doing? Creating a so I'm creating a +1 transducer, creating a +2 transducer, both using map. I'm creating +2 using composing the transducer +1 and the transducer +2. Now I have that, and I'm creating +4 using the +3 and +1, right? So it's just happening. That's a very convoluted way to add 4 to every item, right? So,
by that logic, you could have composed transducer +2, you could then compose transducer +1, transducer +1.
yeah, that's right, yeah.
Oh, God.
Yep. So you can compose these as many times as you want, and actually, another thing you see is actually, it doesn't have to be just one compose. You can create a transducer +3. So transducer +3 is actually created by composing other transducers. You can use that result and use it to compose again. So it doesn't have to actually be in one step. I mean, it's always going to be the same result. It's going to accept a transformer, return a transformer. So you can use compose any place you want. Okay? Well, so this gets annoying fast. So, I mean, really the problem is we have compose 2 here. We don't have to use compose 2. We can use a general compose that accepts as many functions as we want, right? So this is exactly the same as compose 2, except for it'll accept as many arguments as you pass those functions. There's other ways to write this, but really all it's doing, same thing we saw in compose 2. It's returning a function and then executing right to left, returning the result from every function right to left, just like we saw in compose 2. Okay? So using that, well, I don't have it, but if you go back, you could actually just use, instead of using compose 2 here, you can say compose +1 +1 +1 +1, or you can do compose +2 +2, whatever you want to get +4, right? And so you don't need 2 items. You can do as many items as you want, or functions as you want to compose, and that's all this is doing. it accepts, accepts functions as arguments and it composes them right to left. Yeah, so this is just talking about this composed function again. Here I'm passing in +1, +1, +2. So that's 1, 2, 4. So if I pass 5 to that, I'll get 9. And all that's doing is this up here. We're just doing this manually, right? But bringing this 5 outside of this composed function. And that's, I mean, that's pretty much the definition of the composition rule. Oh, I guess I did that, I guess. So here I'm creating a transducer, +1, +2, so it's 3, 4, 5. It's a +5 transducer, right? So, and that's what you see, you add 5 to every item. So I have an array as a comment to every item here. But remember, this is actually not creating arrays at every step. You're actually running one item at a time. So you're gonna, every time you run an item through this list, the composition is right to left, but the way these are set up is actually, and we'll see this in a bit, but this actually runs, on this case, top to bottom, but left to right. So when you pass this through, it's going to add to this +1 transducer, so you get 3. If you pass 2 first, you get 3. Then you add 2 to it, you get 5. Then you add 1 to it, you get 6. And you get 7. But remember, this is actually one item at a time, so you're going to get just one array that you're working with at the bottom here. That's going to be passed through the pen. This empty array here, it'll pass through this whole chain to a pen. You're only working with one array at a time. You're just doing one step at a time. So when I have these comments out of the side, that's just to indicate what the step is doing. It's not indicating that it's actually creating arrays there. It's just showing the operation, what would happen if we stop there, if that makes sense. So again, we're creating a transducer here by composing other transducers. We can compose as many as we want. And here we're just using, just like we saw before, transducing a pen with an array and transduce. Any questions? Okay, so looking at math again, this is what we've been using all along. We're passing in our function, accepting a transformer, returning this transformer, but the only thing that we're actually changing every item with this function we're passing in. So that would be our +1 or +2, whatever we're passing in. So we can do other things with this kind of setup. One could be filter. So here, this is the result. I'll show you a filter on the actual implementation on the next slide. But filter is a way, I mean, you've probably seen it before. We're creating a predicate function that is accepting a number and it returns either a Boolean value, a true or false value. So here I have an is-odd predicate. And I want to filter my list from my array of 1, 2, 3, 4, 5. I want to filter all the items that are odd. So it's creating this transducer called filter. It's creating a transducer using filter by passing an is-odd predicate in. Everything else is the same. Initial value, the pen, and the transduce. So how is this implemented? Well, so this is math again. Really, the only thing that's going to have to change here, the initial value is not really used in this case, so that can just forward on to the next one. The result is just identity again, because we don't have to do anything. We'll see a case at the end where we're going to change result, but really all we're concerned about, the most important thing, is the step function, what we're doing with every item in the list. So.